Okay. This is how you bring your georeference map and create an animation. So there is not much going on right now. You just have inflows and outflows you can view. Let's see on our slice view, or the vertical view, how it looks like. For example, if you want to look at this line in your let's go ahead and inspect what is the I and j of this cell. So this is the cell that has an I index of 10 and j index of 28. Let's go ahead and see if it's changing, I changing or j. So I is fixed for this line. So if we extract the vertical slice for I of 10, it would give you the output for this line here. Okay, so let's go ahead and click on this view 2D vertical slice button. So after you click that, then it will ask you what option you want to choose. Well, you want to specify I, J, or a drape line. So this drape line is nothing but a polygon with a P2D format or something. So let's go ahead and click on I of, remember the number 20? I'll just write 20 and see what happens. Click OK. So now you will see your model will have one layer, because we haven't specified any multiple layers. So you can see by default it's showing density of velocities. So the reason there is no velocity sign is because our scale is too high. Let's go ahead and trim it down to 0.01 and see if we can see velocities. Okay, you can see velocities, you can see water column. So now you can see your velocities like this. So it's not interesting at this point because you just have one layer and very small velocity that's controlling your system. I'll just close for now and then add salinity into the system, make it 5 layers and see how it works. So far we saw the model is working. We created a quick animation, saw the slicing of the model at I of 10 or I of 20. So I'll go ahead and save this model here, go to the root folder, name lake tho sal, because I'll be adding salinity into the system. Click OK. Sal based on lake tho. So what I will be doing is activate salinity, and then we will include wind, add wind. Okay, so let's go ahead and activate wind, salinity in our model. So in order to activate any new modules, go ahead and click on activate modules on the left. So I'll wait for a few seconds. Let's go ahead and activate this salinity. Click activate salinity, and as you click, you'll notice there will be a new tab that will be created. That's salinity. Let's go ahead and assign our initial condition for salinity. So we'll assign initial condition at 0.2. Q is constant. Apply. Done. So to make it a little bit more interesting, let's go ahead and increase our assign our inflow boundary condition of salinity to be 5, because in example it was just 0.5 and it's hard to tell what's going on since it's ad hoc test. Go to time series data and click on edit here. So it will bring a form that says data series salt. So what I did, clicked on this edit button, or you could go back to this domain and look here salinity and click on E. It will still take you to the same place. Let's go ahead and create one series. Yeah, we'll be creating one series. So we're going to introduce a constant salinity of 5. So even if you're introducing constant salinity of 5, but the total salt that will be coming in will be determined by the flow. So it will be flow times salinity. So that's how salinity gets entered into the system. Let's go ahead and specify time from 0. At time 0 you have 5, and at time 300 you have 5. So you covered anything in between 180 to what is the end time, 212. So I think it should be fine. So I just went through from 0 to 300, so I cover everything between the run times. Let's go ahead and click OK. So what we did, activated salinity, assigned 0.2 concentration initial at all the cells, and then added a time series with a concentration of 5. Next we are going to do is add a wind into our system. So in order to add wind, what we're going to do, let's go ahead and click on E next to wind. So we'll add a wind series. Click 1. So because we'll have only one series. So when you're providing a wind series in your domain, so it will ask for time, speed in meter per second, meter per day if it's using EFTC Explorer. So you can expand it and see what are the units that you're going to provide, and the wind direction should be direction towards. Okay, so we have provided the data for that. Let's go ahead and find out. I'm going to copy and paste this time, so you know it's easier. Let's go to BC_winds. Double click that. So the format of this one is different than before, so it doesn't have that number. The reason it's different is just so you can use different formats. You can use copy paste, several ways to do the same thing. Copy, I copied that data and I'll just paste it here. So now you have data from -154. So the reason it's 154 negative here is how do you find out what's the time, right? So convert, there is a convert utility here in EE. It's available from multiple places, but if you want to find out what was the actual date for when the Julian date is -154, you can write -154 here and calculate. So it was the date from previous year, that's 2016, and the month was July 31st. So it all depends on your base date. If your base date is 2017, any date on 2016 would have a negative value.
So the direction, so most wind data is direction from, right? So you have to reverse it.
Yeah.
So if you have like airport data, a lot of times it's direction.
Right. So if you enter into your WSER file and if you edit, it will ask to, but somehow EFTC Explorer converts that and then puts it in the direction towards format, even if you change that format to 2.
Okay.
So it will just it just converts towards.
Oh, okay.
Let's go ahead and look at WSER file after saving, and then it will have options. You can choose whether it's flowing towards or towards or from. Yeah. So after you have your wind speed, now you can see the wind rows, like summary of your wind data. Click on wind rows, and then by default it will choose all the time, but if you want to just look at the 30 days you are interested in, click on use runtimes and click OK. So here you can see at what percent of data is flowing, wind is blowing towards what direction. So towards north, it's most of the times it's towards north. That's what, 30 some percent, and you can choose how many bins you want to create. You can go to a format and you can change the sectors. You can change outlines. Sectors is this, how many sectors, 1 2 3 4, and you can also change the bins. I would let you guys play around with this. And another interesting thing you can do is you can bring this plot into the view plan. Let's go ahead and see. Format. Oh, that's probably the velocity rows. That's a velocity rows, never mind. I'll show you how to create the velocity rows as well. So this is how you see your you create your wind rows. You can export to your meta file or bitmap or ASCII file, and then you can use in your report to summarize your wind data. On the top, it gives what was the time period that you used to calculate this summary. It was from 2017 July 2 to August 1st, because those were like 182 to 30 days. So that's how, and it also says on the bottom how many records were there in order to calculate this summary. Now let's go ahead and click OK. Oh, that format wouldn't work if you use the import.
Oh, okay.
Because it's required 1 and 1, but we need 3 rows. So it has to be in different format when you save it. It has to be 2 files if you were to introduce. Yeah, I think it's easier. It's different from flows where you distribute into layers. I think one thing we haven't done is tied the salinity boundary to our inflow. Let's go to domain, grid, edit, review, and then click on inflow, then click on edit. So here you'll notice you don't have any salinity series assigned. Let's go ahead and click on that drop down menu. Seems like I didn't rename my salinity boundary file, but it's fine. I'll just select series 1, because I know there is only one series on this example. Click OK. So now if you click on inflow, you'll be able to see what salinity series was used and what flow table was used. Let's go ahead and click OK. Let's go ahead and so now let's go back to our model. Now that we have tied salinity boundary condition to our inflow, and we have also associated wind into our model, let's make it 5-layer model, and it will be more interesting to see what's going on at different layers. Make it go to domain, grid, and change number of layers from 1 to 5, and then hit enter. So it will make your model now 5-layer, and each layer will have 0.2 thickness. So regardless of what number of layers you have, your total fractions should always sum to 1. So remember, this is a sigma stress model, so we are using 5 layers on all the cells. If you were to use sigma z, you would select sigma z, and there are 2 different options, and then it will ask you what is the minimum number of layers you want to have and maximum number of layers. It can be from 2 to 5, and depending on the higher depth cell, it will assign 5 to the maximum deeper cell, and the shallow cells will have values from 2. Now let's go ahead and save our model. I would want to add another information on my notes, like 5 layers. Let's go ahead and save it. So now I'll go and run and I'll get the same message like you did. It should say anemometer height was not set, so it means we need to specify at what height the wind speed was collected. For this example, let's go ahead and enter 10. But that would depend on from where you get your data. From regional airport, if you get it from regional airport, they would usually say it's either from 2 meter or 10 meter. So there is an equation internal to the model. So even if it's a 2 meter, so it will try to calculate everything to 2 meters. Even if it's 10, it has a conversion, and then it will convert to 2 meter. Let's go back to domain, go to boundary conditions and click on edit next to winds. Then it will bring that back the same form. So parameters, if we know the latitude and longitude, it's better to provide latitude and longitude, but it's not required since you are having only one time series. But if it has multiple time series, multiple wind series, then it's better to have latitude and longitude. Let's go ahead and fix the anemometer height here, wind station parameters and anemometer height to 10. So these are all so it asks, please provide latitude, longitude and or grid coordinates. This information is used for determining series weighting. This is required if you have more than one. So I have just one, I will just ignore it. Yeah. Now let's go ahead and save it. Now it should be able, you should be able to run the model. For hopefully it runs faster. You see, at first it was 0.4 and then 0.9, 0.17. So it will be done soon. It's interesting, today it's running much faster than yesterday. Let's see what happened. Okay, let's wait for a couple minutes for the model to be done, then we can look at the results. So this number here, it's telling you the time in days, and this is the time step that's being used in the model. And this elevation is the 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 water surface elevation of that cell. So it's 1150 centimeter, means 11.5 meters. So it's not changing a whole lot. That means that whatever is coming in, going out, there is very little difference. So when you have this is a very simple example, that's why you're seeing it's constant. But when you have your inflow time series is different than outflow, or you have a downstream boundary, that would be water surface elevation, you would have too many differences, and it will change each time step. That you can view it here. And VLE is velocity in east direction. That's the particular cell that you assign. Yeah, if you go back, right. Yeah, that's the east to the grid. Mm-hmm. So what EFTC Explorer does is, when it's process the velocities you get, it's on the cell centroid. But when you are calculating the flows, the velocity at the cell faces will be used to calculate the flow between the cells. For display purposes, it will automatically take care of the rotation, grid rotation, and then it will give you the cell centroid velocity. But the cell face velocities and cell centroid velocities are different things. So if you are interested in cell face velocities, you would have to use manually output that. You would have to write a little bit of code. By default, it's always giving you the centroid velocity. But if you create a flux line in order to extract the discharge along the channel, it will still use the phase velocity, so you will get the right flow. So these are viscosities. So if you go back here, Hydrodynamics, horizontal viscosity. So these are AVO and AB, vertical area diffusivity and vertical area viscosity. So we didn't change a whole lot. So it's using Miller and Amada vertical model in order to calculate those numbers. So those are that. Then it's velocity at the bottom cell. So it gives velocity at the surface. Right now we had 5 layers, so you can see it's different at the surface and it's different at the bottom. And then it gives die at bottom, and the AV and AB at surface and bottom. So if it was only one layer, it would have the same values. Right now here AV is 10 and 13, but on the bottom it's 0. Yeah. So let it run, and at the end I'll show you. It will display the time taken for the model to complete, and it will also say which subroutine or which process took what much time, how much time. So for example, if you see your water surface elevation is jumping up too much, that might mean your model is not stable. So one time it's like 1, one time 20, then 1. It's like too much fluctuation in each time step. Then you might want to pause your model and go over and look into your water surface elevation time series and see if it's realistic or not. Yeah, this screen will give you a lot of information. Right, on any button, and then if you hit the same button, it will just finish. And here are the several information like SDMT. This is a hydrodynamic. So the time spent for the hydrodynamics was 0.054. PUV, the time spent in that PUV subroutine in the model was 0.056. So from here you can tell how much time was spent in what subroutine or what processes. So set tox is 0 because there was no sediment and toxic in this model. So the conjugate gradient is a solver that EFTC model uses to solve these equations. So it's a very minimal time over there. This is a vertical viscosity, it's 0.05, turbulence, and heat. Heat is 0 because we haven't activated temperature. So this alone would give you a rough idea about where your time is being spent when your model is run. I mean, it can be 0 or yeah, sometimes it's really small. This can be 0 as well because your velocity E, yeah, it's always 0, 1, 2, trying to round up to the nearest digit, so it's pretty when you display it. But when you look into the real results, it will be some values. Okay, so after your model is finished, it will look like this. Let's go ahead and tap any key, and then we will be out of that window. Now in order to view the results, we'll click on the same view 2D plan. Now let's go ahead and look at our salinity patterns, how it looks. After a certain time, I think it will probably reach around 5 or so in all of the regions because it's always constant 5 coming in. But let's go ahead and see if it's the case. So I think it's better to do animation and see what's going on. Go ahead and do the animation. You can hit Control Alt A, is not working. Control A, and it will take you to the animation window. And animate to AVI, no. I'll still use 0.1 time lag, and let's go ahead and click OK. So you would see, let me add one more thing to this animation to make it interesting. Let's go ahead and add the timing frames and see what is the actual flow coming in here, and what's the actual flow going out here. Okay, let's right click here. So this is general options, velocity options. Now let's go to boundary groups. So in order to go to these kind of options, you can always go to this display options on the top, or right click on the legend to take you to the same form. Go to boundary groups. So here, now let's go ahead and go to show timing frame control. Click there. So here there is nothing selected. Let's go ahead and create a new timing frame, and let's give a name. So after you have created a new, you have to select which these are the available boundary groups that you want to show in your view plan. Let's go ahead and click on inflow, and by default it will change to inflow. If you want to change the name, you can do it. So the scale here for the inflows and outflows is 1 means 1 day. It will show you the data for 1 day. If you want to show the data for 5 days, let's say 5, so it will show you the hydrograph for 5 days. Okay, so the top is empty. I can just make it out, link to outflow, and it will be outflow, and I'll scale it to 5. So you have inflow and outflow, and the scale is 5. However, when you add wind into your system, the scale in wind is scales to the wind velocity or wind speed. So if you say wind velocity of 5, everything will be scaled to the 5 meter per second. Scale 5, let's get everything to scale to 5. And here are options. Do you want your timing frames to be resizable? Do you want it bigger or smaller? Let's make it resizable and put borders on it, and click OK. It just threw me an error. Did you get the same error? That's a bug. Let me close and come back. Error during the plot key setup. Let's reload the model and see if it works. Okay. Now let's go back to the same timing frame. I would add only one for now to see if it works. Okay, so it did work this time. Not sure what happened. Go to timing frames again, add a new one. Name it outflow, scale 5, inflow 5. Also add a wind. Should work. Okay, this time it worked. Not sure what happened last time. Okay, is it working for you? So now you can put these on next to your boundary conditions, so you can you know how much flow, what is the hydrograph looks like. And this small the vertical line here shows this is the current time, and this is your current flow that's coming into your model. So there's it doesn't have the actual number, but you can see whether it's increasing or decreasing. You'll be able to tell the high flow or low flows. So if you select somewhere in this window, let's say you want to go directly to this point, you right click into that timing frame, and then it will tell the program to go to that particular time, and you'd see the time would change. And let's say we want to go to the high flow case and see what happens. Go to time. Okay, this might be the high flow that we are interested in. Now let's go back to water by layer and look at salinity. Now let's animate to AVI. No. Frame delay 0.1. Now you should be able to see at each time step wind is also changing, your inflow hydrograph will be changing, and outflow hydrograph will be changing, as well as the numbers or the salinity values in your grid will be changing. Let's go ahead and click OK. So you'll see slowly the salt water will be coming into the system, but depending on how long you run, you will be able to see the salt plume. So you can see the salt values are slowly increasing in the system. But not by a whole lot, slowly. Okay. So after the model run is finished, it will just try to loop around. So let's go ahead and stop. So now let's look at, so I was looking at depth averaged. So if you look at the first layer, salt water has a higher density, so your bottom layer would go further than your surface layer. So if you look at your bottom layer, it goes all the way here. So you'll be able to see more interaction when you select the bottom layer. Let's go ahead and create animation again and see what happens now. You can see a nice plume of salt water going here. It's much clearer now compared to the depth average, and everything is changing at each time. So you can tell right now there is very little flow coming in, so there is not much interaction. I think for this 30 days that we have selected, there is not much high inflows coming in. So if it was a really high pulse of flow, these areas would, or I mean, go to the higher salinity very soon. Okay, so that's that. Now let's go ahead and look at our velocities and look at velocity rows. Let's go to velocities. It looks random now. So if you right click when you are in velocity mode, you would have four different options. So you can have either profile, velocity profile. So what I did was went to viewing options, velocities, and just right click on any cell. Okay, let's say I want to have a look at the profile of velocity from this cell to somewhere over here. I'll just right click here and click on profile. Then it says the new profile starts from this point, and it is asking me assign the last point where you want to see the velocities. Let's say on this line, right click. Then you can see how velocity is changing at each during on that line. I think this is a nice little way to see how your velocities are changing. Let's say you are interested, this is inflow and this is outflow. You are interested in kind of center line that goes from inflow to outflow. Let's go ahead and create quickly a polyline which connects this inflow and outflow. Just show only the magnitudes for now so it's clear. So in order to create a polygon or polyline in EFTC Explorer, here is a pencil like icon on the top that says activate polyline tools. Click there. So after you click, there will be a bunch of small tools that will appear on the left. So these are similar to the spline tool that we work on CVL grid. Now let's go ahead and create on the first that says drop polyline. Click that, and then I will start right here where my inflow is located. I will just try to make a straight line or a line that tries to follow the flow pattern, and then I would end right at the outflow. And in order to end this polyline, just right click, and then after it's done, it will give you this information: enter a string ID. So I would write a center line. I would write the name center line from inflow to outflow. I just write too much information. Click OK. So now don't forget to save your polyline. So that's the P2D format. So it saved the points between this and that, this inflow point and outflow point, and all of those are stored as name whatever I gave. I'll save the file now. So it will go, by default it will take me to analysis folder. That's fine. What do you want to name it? I would write central line first because it's a central line, so it's easier to access it later. Central line inflow dash outflow. So it's explanatory. It's a central line that connects inflow and outflow. Let's go ahead and save it. And there are several options that you can save it. You can save it to P2D or DX format, LDB, depending on the extension that you choose. So if you don't choose anything, by default it will create a P2D format, and that's what we're going to use. Let's go ahead and save it. Now we can get out of this polygon tools. Click on the this button here, and then it will remove the options. So now let's go ahead and look at longitudinal profile. Okay, so in order to look a longitudinal profile within a view plan, let's go ahead and there is a button here, longitudinal profile, on the top. Let's go ahead and click that. So now it's asking you want to use a drape line, I or J. Now we have created a drape line, right? Let's go ahead and click on use drape line, and how many layers you want to have. Let's say, so let's go ahead and press F4 when you are on this text box, and it will give you options what you can choose. Click F4. So if you want to choose velocity, and choosing the value of 1 would give you x, y magnitude for that region. If you choose 2, then it will give you only the x component. If you choose 3, that will give you y component. 4 would give you g component. 5 would give you x, y, g magnitude. So let's go ahead and look at only x, y magnitude for now. And okay, I'll just do that. Velocity options. Okay, 1. Now if you click show, that option, F4 again, see what went wrong. Looks like I have to provide 2 options. So I have to give 2 options. First one is you need to say which layer you want to extract from, and the second is what information you want to extract. So this is unique to velocities. For other layers you can just define the parameter. Now let's go ahead and select this bottom layer as 1 and comma and 1 comma 1, that would take xy magnitude. Let's go ahead and do 1 comma 1 and see if it works. Click show. Now it will ask us what was the file that you were trying to use here. By default it just took me to the location where I saved my P2D file. Click here, click open. Now it went and took the exact location where you told the program to find the velocities. Yeah, it's a really nice way when you're dealing with bigger water bodies and you want to see what's going on the central line. And now you can create an animation here as well. So we started from inflow, so this is our inflow location, this is our outflow location. It's depending on where you choose your starting point, that's how this distance is calculated. So the total distance was from 0 to 3500 meters. So in order to animate or go to a next time step, on the top right here is a button you can click, and each time step you can see how the velocities are changing. So in order to view it more clearly, I would like to fix my y-axis. By default it's automatic scaling. I would change this from 0 to let's say 0.05, and we can come back and change if it requires more values. Okay, and I want to change this Julian date to real date. So here is a button. It's like this red button, looks like a book to me. Click there and it will toggle back from Julian date to a real date. And outflows, I'll put it here. Inflows is next to where the inflows is located. Now I will create an animation and look how it looks with how it changes with time. Snapshot skip 1 frame delay 0.1. Click OK. So you can see, so you'll notice when there is a higher peak, your velocity will increase here, and when there is a higher peak here, your velocities will change accordingly. So that's how you see how your velocities or any other parameter is changing into the system. Now let's go ahead and see if we can save this in our model, because that's what we will be presenting when we were presenting any results. Go back to animation again, and this time let's go ahead and click yes. So it will give this form where it says so by default the name will be LP, that's a longitudinal profile underscore. So after underscore you have to write what is the name you want to give. LP underscore velocity profile from inflows dash outflow. Okay, so and it asks you what is the time you want to extract the animation. Is it by default the total run period, or you just want to extract for a few days? Let's say I want to extract for 10 days or so. So start animation is from 182 days, and you want to stop it at 10 days. And here are a couple options you want to choose. You can choose to display output every 3 hours or every 2 hours or every 1 hour. So depending on what number you choose here, the size will be bigger. So if you choose for 30 days with a 1 hour interval, it will be a really big file. So you want to figure out the time period that's really interesting. Okay, so right now I don't care about that. I just want you to show I just want you to show you how to save it. 10. And if you want to change the number of frames per second, you can choose it. I'll just put 1 and 1 and then click OK. So the program will go ahead and do the calculation and save the snapshot for each time step, and at the end it will create a animation file for us, and it will save to the location where we specified. So after it ends, it will automatically stop and we can go back to the folder and look at the animation. Okay, now let me go back. Okay, so one more thing here. What here you came to this setting and changed a bunch of things. Now you want to save these settings. Another time in future you come back and you want to have the exact same settings. You don't want to spend a lot of times to show where your inflow time series would stay, what would be your bounds. So I would like to save my settings of this so that I can have the same setting every time. Save settings, and again it's important to write the name. I'll write settings first, dash profile underscore velocity magnitude. I think that should be sufficient. Let's go ahead and save it. Yeah, and in order to use that setting file, you can use read settings and then point to this file with the extension DSG. So the plot settings will have the different extensions, so it's easier to distinguish what type of file you're looking at. Let's go ahead and click cancel. Now I will go and find out my animation file and see if the model did something or not, if it really saved it. Control V. So now you'll notice you have this animation folder, and you have this animation. You can go ahead and play it. By default, this Windows player might not play, so you might want to use Windows Media Player. In Windows 10, there is this program TV and something it tries to play by default with that. For this program, I have manually changed my configuration so it plays with my Windows Media Player. So here you'll notice that it's changing very slow. It is time step, so it's not important to show this slowly. You could change you could skip every 3 or 4 hours. You can go ahead and do that later. So now let's go ahead and look at profiles. We will look at this slice on slightly different settings here. Go to view 2D vertical slice, click here. So this drift file is selected because it knows we just use it on the longitudinal profile in view plan. If it's not there, let's go ahead and browse that file. It's a central line inflow outflow. So you will notice there will be two files. If you have used a P2D file in order to create a profile, it will create a EEL file and P2D file. So what EEL file is, it will find the exact location of what point we are going to use in our model. So it doesn't take extra computation for the model to calculate what were the cells selected in that polygon. You can just go ahead and use this EEL file, or if you want to use P2D, that's fine. I'll just use P2D for now, and you'll notice it will take a little bit time, so you'll try to find out the location. No, what is this blue line at the bottom? Okay, so now let's go ahead and view salinity here. Right click and view salinity, show grid. Okay, can you see anything? Oh, the reason it's not showing anything, it's because your elevation is wrong here. Let's go ahead and fix the elevation to automatic. Now it will show you your cells on that drip line. Okay, so by default it shows salinity from 0 to 35, but our maximum salinity we're provided is 5. Let's go ahead and fix that 5. Auto precision, that's fine. Click OK. So now this is our inflow, this is our outflow. We can also see the animation. This type of animation I showed a lot when I was doing this issues and solution section. So now you want to show what, for example, there is this dam over here, or there is this location where you are interested to see what the results are. We can create a marker file. So right now we'll just create a random numbers. Let's say marker 1. It would be a breeze. There is a breeze somewhere where you are interested, and in order to find that breeze, you would have to find I or J index, and based on I or J index, you can be able to find the distance. But for this example, I'll just use 1000 as the breeze. Second is field station. Let's say there is a station where you want to see what it looks like. It's around 2500, and you can have the starting point as inflow. You can show it inflow, it's around what 100, and last point I'm going to include is outflow. That would be at a distance. So this value, it's asking you the distance, or this x-axis. So if you want to have a marker this line, this direction, you would have to change to y value. By default it just changed to did our x value. This is where we want to show our different locations. Outflow is around 3500. So you are done saving this information. Let's go ahead and click OK. Oh, so you need to make sure you're using the marker to visualize on the um, on your model. So make sure to click use marker. Hopefully it will show it now. So now you can see there are 4 different locations where you can show the values, or you can show the locations. Say, oh, this is where my bridge is located, and it is not, the salinity value is around what 0.23 at this point, but at the bottom you can see it's around 0.7. So you can create an animation of this view, and you can change the color and format of these marker files and make it pretty when you're trying to present. And you can see the salt water is coming from the bottom, and this is where fresh water is on the top. Salt water is in the bottom. If you decide, you can have an animation, and you can also plot these values as contours. So on the top there is a show contour. If you click there, by default it will change to whatever the program does, but you can have control on contours. So let's say you want to have a minimum contour from 0 to 5, right? So it will have a major interval of 1 and minor interval of 0.5. That way it will have total of 11 contours. Let's go ahead and click OK. So it will show this is a salinity contour of 0.5, this is 1, 1.5, 2, and it's shown as a color on the top. I think the settings look good, but the overall model doesn't have much going on. In a real scenario, I think this would be the good time to create animation and save. Now if you want to save this layout, you can hit Control K, or Alt K on the screen. So next time you come to this profile and you want to load the settings from the settings file, so everything will be exact position. So your elevation will be from 7 to 11.5. You will have your markers, and you will have these contour settings.
Where is that? You don't remember all
So every time if you hit F2, so it will give you all the shortcuts. So the options will change depending on what view you are in, but there are so many keystrokes that are not available right on the top. Yeah, for example, if you have a time series and you want to plot a whisker plot right out of time series, you are able to do that.
Okay.
So I would encourage you guys to check these functions, and it would make your life easier. For example, if you want to toggle from metric to English units, you just hit Control M and it will change the units for this. Let's see if it works. Yeah, it changes from distance to meter. So some people might prefer English units when you're displaying results. Yeah, if you want, you can create an animation. I'll just get out of this. Let's see what else I want to show to you. We could run another model with temperature, but I'm not going to do that because it's a similar process like what we did for salinity. So the only thing that you need when you're activating temperature is you need to provide your atmospheric data. Let's say I would save this model as I'll just show you how to create a model. I want to run it. I would save as a lake THO temp. Save it. Let's go to description and update our model description. lake THO attempt based on lake THO cell. So we'll have temperature, atmospheric series. Okay, so after you have activated this temperature tab, you'll temperature submodule, there is a tab called temperature. Now let's go ahead and import our temperature atmospheric data. Click edit, and then I'll enter the series 1. So you'll notice when you are entering data for atmosphere, you need a bunch of different data. One is atmospheric pressure, that be in millibars, and T dry is your air temperature, T wet or relative humidity, you need to have that data. Rainfall, evaporation, solar radiation, and cloud cover. We have provided that data to you on that data folder. So if you go to that data folder and open the atmospheric data, you can go ahead and copy everything, Control A, Control C, Control V. So now you have all the data you need in order to run the temperature, and it will have the atmospheric heat exchange. And here if you look solar radiation, the values are changing at each hour. Here it's 135 to 91. So if you want to see how your data looks like, let's go ahead and view series and click on current, and I'll just click OK. So it will show you all the parameters on the same screen here. Now, so the one on the top is atmospheric pressure because it's the one that has a higher value. If you are just interested in it to see what your temperature looks like, let's go ahead and right click on this legend and hide everything but temperature. Select everything and click here, general options, show, and then I'll go back to dry bulb temperature and click on show, and then click OK. So now it will show only the temperature here. So this is your temperature boundary condition, and there are several things that you can do with this temperature boundary condition. Let's go ahead and hit F2 on the screen. Now you have these options that you can use in order to manipulate this time series. For example, if you want to know what is the percent of time the Y value is greater than a specified label, let's say you want to know the percent of time where your temperature is greater than 15 degrees, right? Click F2, and if you hit Control L, let's say Control L, it will ask what is the label, what is the criteria. I'd say 15 degrees. Click 15, then it should return the statistics. Percent of the time Y values is less than 15 is between the times 200 minus 200 to 800, and it's 44% of the data is less than 15 degrees. So it's a nice way to understand what your data is telling. Click F2 again. Now if you want to plot a whisker plot from here, let's see, if you hit Alt S, it will Alt C, it will show the line CDF statistic. Alt 1 would plot your whisker plot. Let's go ahead and see how it looks. Alt 1, then it will ask you what is the line you want to use. Here I have just one. Let's go ahead and click 1, and it will ask you how do you want to average your data. Is it going to be daily, or is it monthly, or you can write 2 months or 1 month. Let's go ahead and see how the monthly data would look like. Probably it's second series, that's the reason it's not showing. Alt 1, 2. Okay, So the reason it didn't show it before, because there are 7 series here, and then I changed the settings. Now I want to extract the data and see how my temperature change each month. And this is a box plot. You can see your mean and your interquartile range. It's a nice way to show the statistics or summarize your time series. If you hit Control Alt 1 again, it will go back, revert to the previous position. There's that. There's one thing you need to fix here, because the data we have provided here is a relative humidity. It's a T wet by default. You need to change it here. On the top it says show parameters. Click there. Already open. Do you see show parameters? Click OK. I'll go back, edit, show parameters. Okay. I need to make a few notes. Okay. If you know the latitude and longitude of your data, why I don't have that. Okay, let's go to temperature and surface heat exchange and fix what surface heat exchange model we are going to use. There are several options that you can use from. One is legacy, that's from original EFTC model. So for this example, we're going to use the equilibrium temperature, or C equal the W2 method. You can you can provide, well, what is the minimum fraction that's absorbed in the top layer. I'll just write 0.3 to point. For example, for a real case, it can be from 0.3 to 0.5. Now let's go back to this series and see why it did not provide. Okay, now it's showing the T wet variable, because I had not specified whether I was using the surface linkage. So even if you provide the atmospheric file, but you don't specify you are going to use this type of method, it will not use the atmospheric data. So it's important to specify the submodel, which submodel you want to use in order to run the model. Now you go back and change that to show parameters, change this T wet variable to 1. So after you do that, you'll notice this T wet here will be changed to relative humidity. Yeah, now it's RELH, and the relative humidity ranges from 0 to 1. So now we have everything we want for atmospheric data. So this is the thing I wanted to point out when you were using atmospheric data. So if you want to compute ice in your model, you go to this button where it says bed heat and ice. You could check, there are several options for ice, but if you're not sure which one to choose, I think it's best to use heat coupled ice with fragile ice transport. Click that, and then it will have several other parameters that you need to enter. Yeah, no, by default it will give you the best estimate. If you are not sure, you can use this parameter and run. Yeah. Yeah, we're not going to do that. Just wanted to point out how to use the ice model. So now if you are going to use evaporation in your model, on the bottom there is evaporation options. There are a bunch of different options, and there are altogether what, 9 or 10. So these are different formulations for wind functions. So the wind functions will be used to calculate the evaporation, so only one equation is changed, rest of them will still be the same. So if you want to calculate the evaporation from the atmospheric file you have provided ESER, you can do that. But if you don't have evaporation, you need to do some estimation, and these different algorithms here would give you options. For example, if you are looking at a cooling lake, this cooling lake here and the WARD, these are the papers which implemented this approach. So if you want to really know what was the equation used in this approach, you can find this paper and see the equations. And I usually use this evaporation from ESER if I'm pretty confident of the evaporation data. Otherwise, I would just change. I think let's not run this model and go back to the salinity model and look at some 3D options, because we haven't looked at any 3D viewing options yet. So I showed you velocity, polygon tools, statistics. I'll go and find out my salinity model. So we have been using this view 2D plan a lot. So if you click on this clock next to the view plan, it will give you the same information that it gave at the end of the run. So you can copy it to your clipboard and do some benchmark runs and compare different times. You can have multiple number of cores for one run. You could have 2 cores for another run. You could have 4 cores, and kind of compare the time and see how fast your model becomes when you increase the number of cores. I think that would be a good study to do. Now let's go ahead and click 3D model viewer here. So by default it will show you this top view. There are several options. If you are lost somewhere, if you are dragging and doing something and you don't know what is your top view, you just click here on the top that says plan and top. It will give you the top view. And if you want to see east and west, how your model would look like, east west, it's just viewing purposes. It may not make sense to present it somewhere, but some of these options, it's informative. It lets you view however way you want to view your results. It will be interesting. Now if you go to your viewing, choose your viewing options to water column. On the top, view options to water column, and then you can choose salinity, and if you drag your screen model top and bottom, you'll see your bottom elevation on the bottom with the gray color scale, and on the top it's a ramp from 0.2 to 0.2. Let's go to some other time and see how your model is changing, how the time salinity is changing. You can zoom it and see. So if you don't want to see a bottom elevation, you want to see everything, you can rotate and see the nice plume flowing on the bottom, and on the top there is not much change. So you can see this is a classic salt example, that the salt water is flowing from the bottom. You can again create animation here, like what we did on 2D. So you'll notice that if you just click on this, you are able to rotate, but you are not able to extract the information what is the concentration at that particular cell. So in order to do that, it's an inquire button like a GIS. You will hit I and then click on the cells, then it will give you the information. And you will notice you will have layer information as well. Layer 5 here means top. So if you go near the bottom, it will give you to layer 2, layer 3. So it will give you the information for all the layers. Another interesting thing I want to look at is cell clipping or blanking controls. Here on the top where is a seizure like symbol, click on the drop down, blanking settings. So there are two blanking settings you can use. I would just use clipping by value for now. So what it does is it clips. So this small option, if you choose use blanking by IJK, then it will use the values on the top. But here on the bottom I am using use clipping by concentration, right? So what right now it's selected density. I would want to go to salinity, use clipping by C. I want to show the values that has salinity from 0.2 to 1. Let's say how many cells are there. That's not what I wanted. Probably 0.5 to 5. So this is the area where you have a concentration from 0.5 to 5, and now if you animate and if you want to see if the area increases as you do animation. So I go to top and click on animation, click no, then just click. So you will see the area will change at each time. The area of this area of the grid cells which has concentration from 0.5 to 5 is increasing. So you can see the impact of salinity. So we are just looking at the particular cells that has concentration that we specified here. Let's say you don't want to clip by concentration, but you are not interested in this half, you are just interested in this half over here on the left. And now you could clip by I, J, and K, and let's say I want to see inquire here, what is the I and J. So J is not changing, so I would change a J from 20 to 29. 20 to 29. Well, it's not doing anything. Let's click here and go to top and use blanking by I, J, and K. If you have a bigger domain and you want to see your grid rotation at the center, and you can use this animate G axis rotation, and you can see how your model would look like, and you can just ISO this type of animation for Caloosahatchee estuary. This is really fast, but I could slow it down to let's say 0.5. I think it's yeah, C means concentration or whatever is selected. So here it would be salinity. When it goes to temperature, so the means temperature. Yeah, when it's selected temperature, it will be temperature. So it will depend on what parameter is selected. So here if you go to others, it will select density, and then you have to provide the density values here. Yeah. And here are different other options: animate index K blanking. Let's say animate J blanking to see what it does. This function is not working. Oh, it's blanking from here. So each time step is blanking. It may or may not provide useful information you want, but I think it's easier to understand. This is J direction, this is I direction, something like that. Now if you want to blank only on I, it will do that. So it should remove the cells from this direction coming this. So you can change the lighting you can change this light button on the top, and you can rotate these and create shadows where you can look at the results better. So this is the option you have. Light colors would change how the concentration would look. So there is that. And here is the option. For example, you want to make a new model. Let's say right now we are on 2017 7/12. It's somewhere in the middle, right? But let's say something is screwed up from this point on. So you want to test another model and create a new model from this point. You just click this save button right here on the top. So this we call hot start, yeah, or warm start. So what it does is it will take initial condition from this point. So whatever values you are seeing, that would be your initial condition for the new model, and then your new model would run from this point onwards to the end of the run. So you save it, and then it will create all the input files necessary for you to run the FTC model. Another thing you could do is animate. This is a really simple example to show this feature, but I want to show you how to create a flight path animation, a really crude animation. So here, click on the flight path animation. Let me find out first what is the elevation. It's around bottom elevation. Okay, so let's go ahead, click here and show flight path tool. So the flight path tool is nothing but a polygon tool that lets you to create a path. So if it's a really big model like I showed you earlier about San Joaquin, Sacramento, it'd be really helpful to kind of travel through that path and see what's going on that particular time step or snapshot. Create a new flight path. I would just go from inflow slowly towards outflow. It may not look pretty, but I just want to show you how to create one. Now let's go ahead and save the flight path to a file. Let's came here. The extension would be .dat. I would write flight path inflow/outflow. Save. Now you can specify at what height you want to see this animation. So by default, if you want to change the height for all the points, you can change it here. It's a 18, you can make it 15 or 14 because your water surface elevation was around 11.5 or something, so it will be around 6 or 7 meter up. Let's try 13 and see how it looks. Click OK. So now we have specified our path, and we have specified that we want to create an animation the 13 meter height. That's another tool. Go to animate flight path. Again, the options are same for all the animations. Click no, then the options will be different here. Frame delay seconds, I would probably even want to make 1 second delay. So the animation step, so how much step do you want to take to go from one point to another? You can play around with this animation step to make your animation smooth. And what is the camera angle that you want to use when you're looking from top? Probably look around 60 degrees and see how it looks. You can change this angle, and each angle would give you different views. I don't want to show the flight path when I do the animation, so I'll just change to false. Now let's go ahead and click OK. So it doesn't look pretty, but it does the job. So you could what you could do is probably go a little bit higher, say 18, and even change your flight angle, flight path options. Not sure what would be the right angle. Let's say 90 degrees, and right beneath what it does. 90 degrees, it's going down. It's going, it's not the right angle. We'll probably use 10 degrees. I think it's better than before. So there is nothing, I don't want to see density. Let's see salinity. So there is not much changing in the models. It's hard to tell what's going on, but if you had run temperature, it would be different on different cells because they will be dominated by your heat exchange. Yeah, the objective is to show you how to use this flight path tool in your next project. So if you had any masks or barrier, you could click here on the right and it would show you that black vertical line that I showed you on Kalushachi estuary. And if you want to show bottom elevation would be showed. Now if you want to change the colors, color ramp, and if you want to change the minimum and maximum values, you just right click and it will take you to the 3D view. For water column, you have this temperature color scale. You could change it to black and white if you want. If you're submitting to any journal, some journals strictly require black and white format. Some would allow you to use this colored. So there are several options you can explore. So right now I'll just change the temperature scale. So bottom elevation, right now it's on the single scale. I think it's better. You can at least see how it's changing. Now if I have different colors on bottom elevation, it will be confusing with the top layer. So some of the other options you could do is you could load a 3D georeference file, and you could load 3D geo DEM option. I think you could use that DEM file you were talking about here. So the format is G3D that you would want to import it. Well, I think that's pretty much it. And